Davis. In this mathcast, I want to talk about how we can verify solutions to systems of equations using our graphing calculator. So what we want to do here is to make sure we have the right answer when we have a system of equations, and we want to be able to reduce those to reduced row echelon form. So let's take a look at an example and see how we can do this. So here's a system of equations. Three equations, three unknowns. And we want to solve this using the Gauss-Jordan elimination method. And what we want to do here is to take this system of equations, write it as an augmented matrix, and then reduce that to reduced row echelon form using elementary row operations, and then we can read off the solutions for it. So let's get started with that. And let's take that equation now and rewrite it as an augmented matrix. So notice what we've done here. We've written the coefficients of x, y, and z on the left side of this augmented matrix. And on the right side, we have our augmentation, so to speak, with the constants of each of those equations. So what we want to do now is to enter that matrix into our calculator and then rewrite it in reduced row echelon form. So let me pull up my calculator here. So first we want to enter the values of our matrix, and we want to do that in the matrix menu. Notice that's in the first column, and it's one of those second key operations. So I'll hit the second key and then hit x to the negative first. First option here is the names of the matrices. We'll use that in a minute. Then our math menu, that's where we do the operations. We'll use that in a minute. But first, we have to do the editing because we want to enter the values for our matrix. So I'll go ahead and hit enter over top of edit. We'll put our augmented matrix in matrix A here. Now remember, in this matrix we had three equations and three unknowns. So in other words, we have three rows to our matrix and four columns. The augmented matrix is a 3x4 matrix. So the first thing we have to do is to enter the size. So I'll hit the 3 and hit enter, and then a 4 for the number of columns. And then we'll get a 3x4 matrix coming up here. And I'll just go ahead now and put in the values of the matrix, and we'll do that row-wise and hit enter after each one. And now notice when I get to the final column, the matrix scrolls over for me. And make sure that you use the negative sign and not the subtraction sign when you're entering these constants and the coefficient values. So here we are at the bottom row. And then we have our last element of 7 entered in. And so there we're done. We have the matrix put in. I'll go ahead and hit second and quit now, just to clear the screen for us. And now let's take a look at the command we want to use to reduce this matrix. We'll hit the second key again and go to our matrix menu. And we'll go over to math. And notice there, by the way, right there beside matrix A, we have our 3x4 matrix that we put in. Now, if I start scrolling down here, I'll get to some operations that we'll need. Right here, I'm at line B, where it says rref, so to speak. That stands for reduced row echelon form. So we want to take that matrix we entered and put it in this reduced row echelon form. And that'll make the left side of the matrix an identity matrix. And then from that, we can simply read off the constants, and that'll be our solutions for x, y, and z, respectively. So since I have B highlighted, I'll go ahead and hit the enter key. And notice it pops up reduced row echelon form for us. And now we need to enter matrix A right inside the parentheses there. So to do that, I'll hit the second key, and then our matrix menu again. Now I'm right here at names. I need matrix A, so I'll just go ahead and hit enter, and then the right parentheses to close it off. And now notice if I hit the enter key, what I'm returned with is our matrix, and it's all the elementary row operations have been done for us. Notice the left side of the matrix is an identity matrix, and then the right column has the constants for our solution. So it appears here that x is equal to -3, y is 0, and z is 1. And so let's just go ahead and sum that up. So we can write the solution for our 3 by 3 matrix as -3, 0, and 1 for our ordered triple that represents the solution. So that's how we can use our graphing calculator to verify solutions to systems of equations.